Dear students, in this lecture we will study about the upper lower triangular matrices and use them to solve the system of equations. So the first one is upper triangular matrix. If all elements below main diagonal of a square matrix are 0, so that is called upper triangular matrix. For example, you see that this is the main diagonal of this square matrix, and below this main diagonal all these elements are 0, so this is upper triangular matrix. Upper triangular matrix is denoted by U, so U is equal to this thing. The second one is lower triangular matrix. So if all elements above main diagonal of a square matrix are 0, then we say that the matrix is lower triangular matrix. You see that in this square matrix, this is the main diagonal, and above this main diagonal all these elements are 0, so this matrix is called lower triangular matrix, and lower triangular matrix is denoted by L. The third one is elements of a square matrix, which can be written as, for example, that is matrix A. This matrix A, this element is in the first row and in the first column, so that's why this element is denoted by A11. A11, this one represents the row number, and the second one represents the column number, A11. Now this element is in the first row and second column, so this is A12. This element is in the first row and third column, so this is A13. Similarly, this element is in the second row and first column, so second row first column, so that is A21. This element is in the second row and in the second column, so that's why this will be denoted by A22. Similarly, this element is in the second row and third column, so that is A23, and so on. So elements of A can be denoted by these notations. In this slide we see that the LU decomposition method. L stands for lower, U stands for upper, so LU decomposition method, R triangular decomposition method, R Cholesky's factorization method. All these three are the names of one person, one method. LU decomposition method, triangular decomposition method, or Cholesky's factorization method, to solve the system of linear equations. So what are the steps to be followed in this method? First of all, we need to write the system and matrix form. You are familiar with this notation. Secondly, we will decompose A into the product of lower and upper triangular matrices. This coefficient matrix A will be written in the product of lower and upper triangular matrices. So the second step is to decompose the coefficient matrix A into the product of lower and upper triangular matrices. That is just like this one. The product of lower triangular matrix with upper triangular matrix is equal to A. This step is very much important to note. This lower triangular matrix, where L, which is the lower triangular matrix with diagonal entries, with diagonal elements 1. Remember that the diagonal of lower triangular matrix will be taken as 1, and U is the upper triangular matrix. Find all elements of L and U by comparing both sides. The fourth step is we need to take a vector, a column vector. This T stands for transpose. When you take the transpose of this vector, that will become in column form. So this is actually in column form, y1, y2, y3, and up to yn. So we will take an arbitrary vector y in column form, this thing, and multiply this y vector with lower triangular matrix and equate it with b, that b, this b. So multiply the lower triangular matrix with this unknown column vector y and equate it with b to get y1, y2 and y3. And the last step is we need to find the solution of this equation, x is equal to b. So find x, which is actually x1, x2, x3 and so on. This is actually in column form because this T stands for transpose. So we'll find this x by using this equality. We need to multiply the upper triangular matrix, which is obtained from here. Multiply the upper triangular matrix with this x and equate it with this y, which is obtained in this step, and that will be the solution of this system. So let us try to solve an example. For example, we are asked to solve the system of equations using decomposition method. This is the first equation, second equation and third equation. We need to write this system of equations in matrix form, and you are familiar with this form. This form is 1 2 2, 2 8 16, 3 7 12, along with the column vector x1, x2, x3 is equal to 2 7 10. So that is the matrix form of this system. Secondly, we need to decompose A into the product of L and U. It means that we need to write A into the product of L and U, and L is actually the lower triangular matrix. What is a lower triangular matrix? In lower triangular matrix, all the elements above this main diagonal are 0, and in upper triangular matrix, all the elements below this main diagonal are 0. But as a special case, in lower triangular matrix, we will take this diagonal elements 1. So all the elements in the main diagonal will be 1, and this element should be obtained. This element is actually in the second row and first column, so that's why this is denoted by L21. L stands for lower, so that's why we denote this thing by L21. That is 1 and this is 0. This element is in the third row and first column, so this is L31. This element is in the third row and second column, so this is L32. So we need these three values for this lower triangular matrix: L21, L31 and L32. And the upper triangular matrix, we see that this element is in the first row and first column, so this is denoted by U11. Because of U, this element is denoted by U11, and this element is in the first row and second column, so this is U12. This element is in the first row and third column, so U13, and all those elements. Now we need to multiply these two matrices. How could we multiply? Multiply the first row with first column. So whenever you multiply the first row with first column, so 1 into U11 is U11 plus 0 into 0 is 0, 0 into 0 is 0. Now the same row, the first row will be multiplied with the second column. So 1 into U12 is U12 plus 0 into U22 is 0, so that is 0, and 0 into 0 is 0, so that is 0. Now the same row, the first row will be multiplied with the third column, so that is 1 into U13 is U13 plus 0 into U23 is 0, and plus 0 into U33 is 0. So that is the product of first row with first, second and third column. Now take the second row and multiply it with the first row and write it here. Now multiply the second row with the second column and write it there, and multiply the second row with the third column and write the answer here. And similarly proceed in the same manner. Multiply this third row with the first column, write it here, and multiply this third row in the with the second column, write the answer here, and multiply the third row with third column and write the answer here is equal to A. This is A, so write here A. Now we see that we need to compare these two matrices. How could we compare these two matrices? Two matrices are said to be equal if the corresponding entries are equal. What does it mean? It means that this first element, you see, this first element will be equal to 1, this element will be equal to 2, this element will be equal to 3, that element will be equal to 2, this element will be equal to 8, this element will be equal to 7, that element will be equal to 2, this element, this whole element will be equal to 16, and this whole element will be equal to 12. So that is the comparison of these two matrices. So see, we write here u11 is equal to 1 from comparison, u12 is equal to 2, u13 is equal to 3. Now from second row, u21 multiplied by u11 is equal to 2, and we know that u11 is 1, so replace u11 by 1 to get L21 is equal to 2. From here, that is the second element of second row, and that is the second element of second row, so this is equal to that. And from above we see that u12 is 2, so replace u12 by 2 and L21 by 2 from there. This is L21, so replace L21 by 2, u12 by 2 to get u22. Multiply these two, convert it towards right side, and we will get u22. From there, that is the that is the third element of second row of the left hand side, and that is the third element of second row of the right hand side, so this is equal to that. Replacing L21 from there, L21 is 2, so L21 is 2, and u13 is 3, so u13 is 3. Multiplying these two and calculate for u23, which is 1, so this is u23. Now this is the first element of row 3 from left hand side, and that is the first element of row 3 from right hand side. From here we can replace u11 from there, u11 from there, this u11 from there, u11 is 1, u11 is 1, and ultimately L31 is equal to 2. And this is the second element of third row of left hand side, that is the second element of third row from right hand side. Now replacing L31 by 2, this is L31, replace u12, this is u12, replace u12 by 2 and replace u22 from there, replace u22 by 4 to find the value of L32. Now multiplying these two, convert it towards that side and dividing by 4 to get L32. This is the element of third row third column from left hand side, and that is the same element of right hand side from third row and third column. So equating these two elements and replacing L31 by 2, this is L31 by 2, u13 from above, that is 3, L32 from below here, that is 3, u22 from there, which is 4, u23 is 1, that is u23. To calculate u33, multiplying these two and convert it towards that side to get u33. So these are the elements for upper triangular matrix, and these are the elements of lower triangular matrix. So in the next slide, we L is equal to 1 0 0, that is L21, 1 0, that is L31, that is L32, and that is 1, and U, that is U11, U12, U13, U22, U23, and this is U33. So we have obtained the values of L and U. Now secondly, because this is the system of three equations involving three unknowns x1, x2 and x3. So we will take y as y1, y2 and y3. That is an unknown column vector. Now multiply this y with the lower triangular matrix L and equate it to B. So we have multiplied this y, this is y, and this is the lower triangular matrix is equal to B, this is B. Multiplying this matrix with this one, how could we multiply? 1 into y1, 0 into y2, 0 into y3, so that is this thing. Now second row, first column, 2y1, 1y2, 0y3 is this thing, and that is 2y1, 3y2, 1y3 is equal to 10. So that is, now this is y1, that will become this thing. Now equating these two to get y1 is equal to 2, y1 is equal to 2, 2y1 plus y2 is equal to 7, and putting the value of y1 from there, that is y1 which is 2, to calculate y2, so y2 is 3, and from the last element, this whole element is equal to 10, putting the values of y1 and y2 from above, that is y1, that is y2, to calculate y3, so y3 is equal to minus 3. So therefore y vector has been obtained, which is y1, y2, y3. y1 is 2, y2 is 3, and y3 is minus 3. That is y. Now the last one is we need to find x, which is actually x1, x2, x3, by equating ux to y. ux is equal to y. U is actually the upper triangular matrix, and x is actually this matrix, x1, x2, x3 is equal to y, which is obtained previously, so y is this thing. Now multiplying this matrix with this one to get this matrix, so this is equal to that, and equating this equal to 2, this equal to 3, and this equal to minus 3. So from back substitution, comparing both sides, row 3 implies 3x3 is equal to minus 3, so ultimately x3 will be equal to minus 1. 4x2 plus x3 is equal to 3, and putting the value of x3 here to get x2 as 1, and from the first row, row first implies x1 plus 2x2 plus 3x3 is equal to 2. This implies putting the values of x1, x2 and x3 to get the value of x1, so that is x1, which is equal to 3. So therefore the required solution is x is equal to x1, x2, x3. x1 is 3, x2 is 1, and x3 is minus 1. So that is the solution, which is obtained by triangular decomposition method, and this technique is very much important with respect to every examination point of view.